Hey everybody, Mrs. Bodechon here. We're going to look at Matter 2 AKS portfolio for 2A. It says, I can analyze and interpret data to predict properties of ionic and covalent bonds. So you're first given all of this information and you're asked to answer it. But before we answer some things, we got to know some basics, right? So first off, what is an ionic and covalent bond? So bonding happens between two atoms so that they can form a full octet or a full outer shell, all right? Now they can do this in a lot of different ways. We're only going to learn two different ways for our class. The first way is covalent bond, and that is where an electron is shared or electrons is shared between two or more atoms, okay? So this is when our atoms are going to come close and our electrons are going to start to overlap and be passed back and forth from atom to atom so that there is a sharing happening. All right. Now, ionic bond, on the other hand, is when we have one atom give an electron to another atom and the other atom will take it. Now, you'll hear this in a lot of different ways. You'll hear like an electron is donated and accepted. You'll hear electron is lost or gained. So you're going to hear it in a lot of different ways. Give and take are probably one of the most common ways you're going to hear this, but that would be an ionic bond, okay? So let's look at all of your questions. So ionic bonds are formed between metals and nonmetals, and that's just because they're the ones that give and take. If we look at the periodic table, we already know about valence electrons, right? We know that these have a few number over here, ones and twos, and they're going to be willing to give those away to get a full octet, while these over here are higher numbers, 6, 7, and they're going to want to start taking to fill that shell to have a full octet. So ionic bonds are definitely going to be a give and a take, while covalent bonds are nonmetals to nonmetals, and that's just because over here they're sharing, they're higher numbers, so they only need a couple. So when they end up bonding with each other, they're just having a sharing relationship, which we call a covalent bond. So a cation is formed when an atom loses electrons, making it positively charged, and an anion is formed when an atom gains electrons, making it negatively charged. So what bond shares electrons? Covalent. And what bond gives electrons? That would be ionic. The next thing is going to be your data table that you're supposed to fill out here. And each one it says, first, is this element metal or non-metal? And then is this element metal or non-metal? And then what would it make? Pause the video, look this up, and see if you can figure this out before you look at the answers, okay? So you're going to need to look at a data table or a periodic table that looks like this, where it's separated between metals, nonmetals, and metalloids. Now you can use the zigzag line as your reference if you don't have a color-coded one, right? To the left is going to be metals, right is nonmetals, and at the staircase is your metalloids. So hopefully you filled in your data table and it looks something like this. Lithium is a metal, fluorine is a nonmetal, which gives you an ionic bond. Chlorine, nonmetal, nitrogen, nonmetal, which makes it a covalent bond. Two nonmetals coming together is a covalent bond. Carbon, nonmetal, oxygen, nonmetal, which makes it covalent. Calcium metal, sulfur, nonmetal, which makes it an ionic bond. All right, now you are asked to do some Bohr diagrams and show the bonding happening, right? So we need to look at this first one. Sodium and chlorine are going to now form a bond. So in order to do a Bohr diagram, we have to go back to the periodic table. So here's sodium. I know I'm going to draw 3 shells because it's in period 3. I'm in group 1, which means I have 1 valence electron. And then I need to do chlorine. Again, I'm in period 3, so 3 shells. But I'm in group 17, which means I have 7 valence electrons, okay? So my drawing is going to look something like this. Let's see, there we go. It's going to look something like this. This is my original sodium atom from the periodic table. 3 shells, 1 valence. Chlorine, 3 shells, 7 valence. So neither one is stable, right? They want a full octet. They don't have a full octet. But when they get together, they are going to form a bond, and it's going to be an ionic bond. And here's why. This element, this electron right here on sodium is going to be given to chlorine. And what's going to happen, you can see these are all in X's, so you can see that it ends up right here on chlorine. It's going to make chlorine negatively charged by 1. Okay, so it's going to form an anion. But over here for sodium, because it loses an electron, that shell has no energy now to stay there. So it disappears, okay? So that shell is no longer there. And what's underneath? What's underneath is a full octet. There's 8 underneath there, right? So sodium is really happy and stable, but it is now positively charged by 1 because it just gave 1 electron to chlorine. So because now sodium is positively charged, an anion, and chlorine is now, a cation, and chlorine is now an anion, positive and negatives, opposites attract, right? So now these two are attracted to one another and they will create an ionic bond. So let's go back. Your second one said go ahead and do oxygen and oxygen forming a bond. Well, if we look at oxygen on our periodic table, it's right here. We're in period 2, but we're just going to focus on our valence electrons. So group 16, which means we have 6 valence electrons, right? So here is my initial oxygen and oxygen. Notice I'm only showing you the outer shell, the valence shell, okay? And there are 6 electrons for each oxygen atom because they're identical. They're just represented with X's and the black dots so you can see the differences. So when they end up bonding together, they each need 2, right? In order to form a full octet. So what they're going to do is they're going to share 2 each, and that is represented right here. This is actually called a double bond. So they're sharing 2 each, and that gives each other a full octet, and they are stable and happy now. All right, so this one is this huge data table that's asking you to fill out all this information based off of this data table that you're given. So these are our knowns, and it's asking you now go ahead and fill in this information. So we're going to look at this really quickly. So what we're given is ionic compounds and covalent compounds, the state at room temperature, melting points, electric conductivity as a liquid, solubility in water, which just means how fast it can dissolve, right? If it can dissolve well or not well, and conducts electricity when dissolved in water. So if we dissolve it in water, does it conduct electricity? Yes or no? So you had to go through each one of these. So sodium chloride, it's an ionic bond, right? Because we can figure that out. There's one metal and there's one non-metal, which means it's ionic. So now we can look at our ionic information to fill this out. So would an ionic bond have a high or a low melting point? Well, here's melting point, and it said it would be high. So we're going to go ahead and put high, okay? Would it have a high or low boiling point? Well, let's look at where it's talking about boiling point. Let's see here. So looking at our data table, it does not directly give us information about the boiling point. So we have to kind of infer, right? If a bond has a high melting point, it's most likely going to have a high boiling point. So that just takes some inference on our point, okay? So high or low conductivity. If we look at our conductivity, we can see that there's 2 different ones. There's conductive in a liquid and conductive when dissolved. So if we look at both of these, they're both yeses. So we can make an inference and say this is high conductivity, right? And then high solubility or low solubility, if we look, it says it has mostly high solubility. So there we go, we put high. Let's go ahead and look at carbon dioxide. Carbon and oxygen are both nonmetal, so it's covalent. So now we're looking at our covalent data. High or low melting point. Well, our melting point is low, so we said low. High or low boiling point, again, we can say these kind of go hand in hand, so low. Conductivity, our conductivity says no conductivity and not usually. So we're just going to go ahead and say low, right? That's a good educated guess there. And then solubility, most have low solubility. So do you see how it's saying these words like most or usually? That means the majority of the time, right? Not all of them, but this is our answers based off of this data table, and that's what this is saying right here. So all answers are taken directly from using the data table based on if bond is ionic or covalent. So these answers are great predictions, but not all answers are accurate in nature. In other words, not every single one of these is going to be correct because of words like most and usually, okay? But they're a good way for us to come up with what we think would be a truthful statement. All right, so moving on, analyze the data and complete the table. So we're given substances, we're given boiling points, and now we have to make a prediction on if they are ionic or covalent. So we're just doing it in reverse. Hopefully by this point, you guys have gotten that high boiling points are going to be ionic and low boiling points are going to be covalent. So this would be a good prediction, right? Now, if you really wanted to know a concrete answer, you could look these up, right? You could look up water, H2O. You can see that H, hydrogen, and O, oxygen, are both nonmetals. So it definitely is a covalent bond, right? So we could look this up for real if we wanted to, or we could just make a prediction based off of our knowledge that we just learned. All right, you guys, that was 2A. Thanks.